All right, 3.2, we're still solving inequalities, but now we're going to do it with polynomials. Here's our first example. This is the kind of problem we're looking at where we're going to solve a cubic polynomial. We want to find when it's less than 0. Really kind of, if you think about this relative to Chapter 2, when we exclusively just looked very in-depth at polynomials. Not a lot of, it's kind of a lot of elements of that coming together, okay? To solve polynomials in terms of inequalities, okay? We want to find the zeros, and then we think about the graph. And what I want to keep in mind with this graph is I'm looking for where is this graph right here negative, okay? Because here we have a less than sign. So what I'm after is what x values could I plug into that cubic polynomial to get negative y values, okay? Well, the very first thing to do is to find the zeros. Here, I'm going to factor. All three terms had a common factor of x. So I get a factor of x out of there, and then I'm left with a quadratic, which, again, that's always a good thing with polynomials when I get it reduced to a quadratic, because I can factor or use the quadratic formula. What's left over here appears to be factorable. Looks as though x minus 3 and x plus 1 will do the trick. And I've got this cubic split up as its 3 linear factors. And I can set each one of those equal to 0 to get the x-intercepts, or the zeros. 0, 3, and negative 1. Okay, now this is significant because I want the x values that make this polynomial less than 0. I found here the 3 x values that make it equal to 0. Okay, so I know where the graph is changing directions. Now let's use this and think about a sketch of the graph. I know right here at x equals 0, it crosses the x-axis there. Over at x equals 3, it crosses there. And at negative 1, it crosses there as well. Okay? The leading coefficient for this cubic polynomial is 1. And that means that the left tail goes down and the right tail goes up. Okay? Now that doesn't tell me anything about what's going on in between the zeros, but again, this a equals 1, tells me that what those tails are doing. And I should mention here, it's cubic, and that told me that the tails are going in the opposite direction. That shouldn't be overlooked. That's important. None of these zeros are doubles, which means all of them cross the graph at that particular point. At negative 1, the graph crosses. At 0, it crosses. At x equals 3, it crosses. I don't know how high or how low it goes, but I don't really care, okay, how high it goes. That's not what I'm interested in. What I am is here I can see that this part of the graph is less than 0, and so is that part of the graph. Okay, I want to express those components of the graph as inequalities because those x values represent my solutions. Right here, this was the x-intercept, x equals negative 1. Okay, and it looks like as I go to the left of x equals negative 1, that's where the graph goes negative. So for the first part of my solutions, I could say any x value that's less than negative 1, those are going to be solutions. Okay, because I can see just from the basic little sketch that I made, any x value less than negative 1 will result in a component of the graph that is beneath the x-axis. Okay? Now I've got this interval right here between the x-intercept, x equals 0, and the other one, which is x equals 3. So anything in between 0 and 3, those are going to be solutions as well. Okay, so those would be the solutions to this polynomial. To make it negative, I need an x value that's less than -1, or any x value that's greater than 0 and less than 3. Okay, those would give me negative y values, which is what I was looking for. All right, one more to look at. Another one that looks to be a fourth degree. Now this one's different because this is greater than. So when I make my sketch, I want the parts of the graph that are positive. And again, those intervals, or those portions of the graph, are dictated by where the zeros are. So just like the previous one, I want to find the zeros. Okay. Now I can already see right here, this part's been fully factored. This has an x-intercept of 4, but I also want to make note of this right here. When I get to sketching my graph, that's a double zero, okay, because there's a factor of x minus 4 squared. Okay, now what's left over is a quadratic. X squared minus 1 equals 0. Adding 1 to both sides, I get x squared is 1. Taking the square root, I get that x is plus or minus 1. Okay? That could have also been factored as x minus 1 times x plus 1. And just to reinforce that this is a fourth degree polynomial, it has two factors of x minus 4. I think it's easy to get this confused with a cubic, but it's got a factor of x minus 1, factor of x plus 1, and two factors of x minus 4. We have the 4 different factors, which is why this is a fourth degree polynomial. Okay, so I've got my zeros here. I've got this one here. All right. I've only got 3 x-intercepts, but that's okay, because with a cubic I can have at most 4. Next piece here is just to mark a little scale on my graph. And now I want to think about a sketch with first marking my x-intercepts. I've got one here at 4. Remember, that's the double zero. I've got one here at x equals 1. And I've got one at -1. Okay. Now, this is fourth degree, and the leading coefficient is 1. Okay, fourth degree with a positive leading coefficient. Both tails will be going up. Okay. Now, 1 and -1 are not double zeros, so as the graph comes down here, it crosses, and then crosses again at 1, and then comes down and just touches at x equals 4. So again, as far as this maximum point and this minimum point, I don't know if those are accurate, but that's not what I'm looking for by making the sketch. What I can see here is that this part of the graph is positive, and here it's positive, there it equals 0, and there it's positive, right? So it looks like really everything other than this interval between 1 and -1, for my solutions, I'm interested in everything else. Okay? So for this first part to my solutions, it looks like any x value that is less than or equal to -1 will be a solution. Okay, I do want to include -1 because this says greater than or equal to, so I'm including my x value that's a 0. Then I'll start right here at x equals 1. These are all positive. Then I get to a 0, but this is I want all x values that make the polynomial greater than or equal to, so I'll include 4, and everything after 4, so I'll take anything greater than or equal to 1. Okay? So if it's less than -1 or greater than 1, those are x values that will make the graph positive, which is consistent with my sketch that I only see one interval, and that's between -1 and 1, where those x values are not solutions, and I did not include those x values. I included everything else. Okay, we'll call it quits there. Make note of any questions, and let's talk more in class if you have some.